All right, guys. So we are going to do our final semester one practice of the year on ALEKS. We're going to be solving systems of equations with both substitution and elimination. We want you to have as many tools in the tool belt as you can. We'll also very briefly review graphing. Um, so for this one, I'm actually going to skip equation solving. There are going to be in your assignment, but because you've seen it so much, and if you've made it this far, you probably don't need that help. Email me or go back to the old videos if you need help with those. I want to really focus our attention on substitution and elimination, checking them each with graphing. So you'll see a question that looks like this as a bit of review. Remember, we've got systems of equations, so it's two equations, and you have three options. You'll have one like this, one like this, and one like this. So this first one, and sorry, we're going to check to see if it has one solution, infinitely many, or no solutions. So this first one, it crosses exactly once. That means it has exactly one solution. And the solution will just be wherever they cross. So they cross at -1, 0. Simple enough. This second one, it looks kind of funny, but they're actually exactly the same line. If you rearrange line 2, you'd get line 1. And since they're crossing absolutely everywhere, that means that there are infinitely many solutions. So we would answer infinitely many solutions. And finally, for this last one, the lines, well, they never cross. They're parallel lines. So since they never cross, there are no solutions to that. Simple enough. Let's solve one with substitution, kind of like we did last time. We're going to do two examples of this. So what we'll do is we'll take, what we'll notice is that you have both x and y, so you can't solve for either of them. You need two equations. So what we're going to do is take y, which equals 3x minus 16, and plug it into the second equation, which is 2x plus 5y equals 5. So instead of y, what we'll do is we'll just rewrite this by substituting. We'll rewrite this so that y is in there. Remember, y is 3x minus 16. So what you'll notice now is that we have no x's left. I'm sorry, no y's left in the equation. And we're just going to simply distribute and solve for x. So at this point, it's just a regular equation to solve after we've done the substitution. So we'll distribute. You get 3 times 5 is 15x. And 5 times -16 is -80. So at this stage, we will add 80 to both sides. I'm sorry, combine like terms, so 2x plus 15x is 17x. Then we'll add 80 to both sides, and we have 17x equals 85. Divide both sides by 17, and you get x equals 5. Now, once again, I've reminded you each time, we don't just stop there. We want a solution that has both x and y. So we need to, we're not done yet. We need to plug that back into the original. I'm just going to pick the top equation to plug it back into. So instead of x, we'll write 5. So 3 times 5 is 15 minus 16. We get y equals -1. So our answer to this is 5, -1. And checking that quickly graphically, you'll notice that those two equations cross right there at 5, -1. Pretty straightforward. Okay? Let's do another one. This one's a little different. Notice that it is solved for x instead of for y. It's going to be the same basic process. We are going to take what x equals and plug it into this equation and solve. So we take x, which equals 3y plus 14, and plug it into the second equation. So instead of x, we'll write what it is, which is 3y plus 14. So 3 times x, which is 3y plus 14, plus 5y, I should say, equals -14. Sorry about that. Okay, just a little typo. So we'll distribute 3 times y, or 3 times 3y, that's 9y, 3 times 14, that's 42, plus 5y. We can combine our like terms, which is 14y plus 42 equals -14. We can then subtract 42 on both sides, which gives us 14y equals -6. Solving from there, we divide both sides by 14, and we get y equals -4. Okay? So we take now y, we're not done yet, and we plug it back into this equation. And you can actually plug it into either one. I'm going to ask to plug it into the first one because it's already solved for x, but you could plug it into the second equation as well. So here's that first equation. There's our y. So we plug it in. 3 times -4, let's get y equals plus 14.
2 times negative 4, that's negative 12, plus 14 is positive 2. So our answer is 2, negative 4. Checking mathematically, we get 2, negative 4. Okay. Alright, we're going to move on to our second method of solving. Our second method of solving systems of equations, we've been doing this for a little while in algebra, is called elimination. What we're going to try to do is line up our equations and add them together to eliminate or get rid of one of the variables. So let me show you how this works. If we solve this following system of equations, we're going to do it by elimination. And so there's a bunch of steps to this. I think the ones you're going to see in Alex are going to be relatively straightforward. So here are those steps sort of listed out. So we start with the two equations. We just write them on top of each other. We want to line up x and y and the number if we can. So that's essentially like it's in standard form. Now it's not that important that you don't have negatives in front of the a term, but we'll get to that in a moment. The reason we want to do this is because we're going to add the two equations together by adding like terms. So we're going to add the columns, which means we're going to add 4x and 3x and add 2y and negative 2y. I'll see why that's important in just a second. So when we add them together, this column would give us 7x. 2y minus 2y would give us 0, and 29 plus negative 8 would give us 21. So notice that there's no y anymore. We just have 7x equals 21. We've eliminated, hence elimination, eliminated y, and we can just solve this. So we have 7x equals 21, divide both sides by 7, and we get x equals 3. Now just like a substitution, the sort of important bit was right at the beginning, and then sometimes it's kind of regular solving. But when we get to x equals 3, don't get excited, we're not quite done yet. So we need to plug back into the original equation. Now, to be super clear, it doesn't matter which equation you pick. I just picked the first one because it's the first one. You could do the same thing with the same answer with 3x minus 2y, right? So I'll plug in x equals 3 into this equation, and we're going to solve for y. So 4 times 3, that's x, is 12, plus 2y equals negative 8. So 12 plus 2y equals negative 8. Subtract 12 on both sides, we get negative 20. Divide this by 2, and we get y equals negative 10. So the answer here would be 3, negative 10. Perfect. That's what you would plug in to Alex. 3, negative 10. Now, of course, there's no graph, but that's just how we can always check ourselves graphically. Alright, so we're going to do another one that's very similar. This time, though, you might notice right away, it looks a little different. Here we have 3x and negative 3x lined up at the term. The whole goal with elimination is we want a term in the top equation to be exactly the same but negative or opposite of the one in the bottom equation so that we can add an elimination. So here it's set up nicely. We'll just check, did we line up x now? Yes, we did. The x's are in the column, the y's are in the column. It's in a sort of pseudo-standard form. Like I said, it's okay if there's a negative here. We just want the x's and y's to be lined up on top of one another. So because we're ready to go, we will add our columns together. So these cancel, 3x minus 3x gives us 0. These add up to 7y, and these add up to 20. So notice we've added and eliminated x. We've added the two equations, and there's no x. We eliminated it from the equation. That's the whole goal here. We've done sort of the important bit in terms of solving it. So now we have 7y equals 21, and we can solve for y in a similar way. We get y equals 3. So from there, we need to plug that back in. Again, it doesn't matter which equation you get. I happen to pick the top equation. You can pick either one. I'm going to plug y in right here. Y equals 3. So 3x plus 5 times 3, that's y, equals negative 6. And 5 times 3 is 15. 3x plus 15 is negative 6. Then we simply subtract subtract 15 from both sides, so this is negative 21. Dividing by 3 gives us x equals negative 7. So our answer is negative 7, comma 3. And we should get that here. Yep, negative 7, comma 3. So there you can see we solved 2 using elimination. We didn't have to do a lot of work. This last one we're going to have to do a little bit of setup before we can solve elimination. So here, you'll notice that they lined up in columns, which is great. Unfortunately, there isn't, like if I just add these, I get 8x and 8y. So they didn't eliminate. So what we would do is find a number that we can multiply, let's just say the bottom equation by. So when we add these, we'll eliminate way to do this is to simply make all the bottom things negative by multiplying by negative. Let me show you what that looks like. So we started our first two on the original equation, and what we're going to do is we're going to end up in terms of perfect. But to get it so that we can eliminate, we're going to multiply the bottom equation by negative 1. I'm hoping that we'll get to see why that is in just a second. So we multiply everything in the bottom equation by negative 1. That just flips the sign. So this becomes simply negative 4, negative 2y, and negative 12. So we've just negated the whole bottom. And now what happens if we add these is you're going to see we get our elimination to occur. We add the columns together, we get 0 here, that's the answer. We get 2y here, and we get negative 16. So notice again, we've eliminated x. We hadn't done that. We hadn't done a multiply by negative 1 business. We would have 8x here if we do nothing. So there's no x, we've eliminated it, and I just have it like we've had the other two. Go ahead and take a moment, pause, see if you can find out what y and x are in this equation. Okay, so if we proceed here, we get 2y equals negative 16. Divide both sides by 2, we get y equals negative 8. Plugging back in, again, to either one of these equations. I just happen to put the top one once again, it doesn't matter. So plug that in, 4x plus 5y, y is negative 8, equals negative 4. So 4x, plugging that in, negative 8. And we get 4x minus 40 equals negative 4. Add 40 to both sides. We get 4x equals 36. Dividing both sides by 4, we get x equals 4. Hopefully that should keep that many pause and plug it yourself. It's very quickly check that on the graph. We could get x equals 9, and negative 8. And there we have it. 9, negative 8. So what I'm hoping you gathered through all of this is that we have now three different methods of subtracting, substitution, and elimination, 3 different ways to solve systems of linear equations.